introduce myself. First of all, my name is Bill Fisher, and I work at Hot Studio here, right over here at 2nd and Howard. And we are a user experience company that does strategy, user experience, visual design, and development. And so we take ideas and we go through the full cycle of them. And we work with large companies and small companies and nonprofits and government organizations and all kinds of people. We have already mentioned this, it's about 80 people. So today we're going to be talking about touch events and also the new pointer event. It is, not only is it important in the sense that all of these you can direct as an avatar remotely. Hands are a lot more direct. They touch a part of our brain that that disembodied avatar cannot. They offer a user experience that is far, far, far superior to the kind of avatar-like thing that people can use as well. And all you really have to do is watch a child try to use a mouse sometime, like a 4-year-old, and watch how much difficulty they have and see how much more direct their experience is with using their hands on a touch screen. It's much more, like I said, it's much more of a human interface. So that's why it's really important that we get this right. I also think it's really important that we get this right because it's clear that there is, to some extent, some conflict between various platforms in our current state of the industry. And if HTML5 wants to present itself as a viable platform on mobile devices, then mastering touch and getting touch really good, right, is very important. So, the agenda today, what we're going to be talking about click, we'll talk about mouse end and touch end and all the different events that you might choose to tie your events to. I'll go over a basic how-to around touch events and explain what the existing specifications describe. And we'll talk about how to get some animation rolling with hardware acceleration and request animation frame. I'll try to go over some libraries for people like you and me. And we'll also talk about, like I said, the pointer events that are coming in Internet Explorer and also possibly for W3C. And I'll go over haptic feedback a little bit at the end and try to touch a little bit on where things might go in the future. So, start with the events. Is the microphone too hot, or it's all good? Okay, good. So, so I'm going to talk about the standard order of events in a tap. When your finger hits the screen, you start with these three. First event is touch start, and which is followed by possibly a touch move if you're moving your finger across the screen, and there could be many of those. You lift your finger off the screen and you get a touch end. There's then a delay at that point. And these trickle in, and then finally we get click. About somewhere between around 240 to 380 milliseconds after your finger first hit the screen. So, and then every other time you hit the screen, you get a mouse out. So the first time you don't get it, the second time you do. So this is the standard order. Most browsers will implement this. However, there are some exceptions, like the Android browser, for example, will do the mouse over and the mouse move first. And that's I think, the one exception I can think of. But there could be also some slight variances. Opera will bring in like a mouse move later in the chain again as an echo. So there's some like weirdness around that. But this is the basic plan. Now, what I'm most concerned about, what I'm most concerned about is the fact that after this, there's this huge delay. So let me go with those delays. So this is what we're looking at. Mobile Safari has the longest delay of all. And this delay is generated by the fact that we are waiting potentially for a double tap. We are sitting there saying, is the user going to hit it again? And then we might fire a double tap event. So, it's really not okay, this delay thing. And just for reference, I want to look at some other multimedia statistics. So in audio, if a vocalist is doing a vocal take in a studio, for example, and they have their own voice coming back to their headphones, a delay of 10 seconds is distracting and makes it difficult to complete the vocal take. At 20 milliseconds, the singer can detect an echo. In video, we have a 33 millisecond frame rate. That's 30 frames a second. And in our actual screens, both the touch screens and on our computers, we have a refresh rate of 60 times a second, which is about 17 milliseconds. 667. So those are some statistics that we could look at in terms of how fast maybe we should be responding. And also old human-computer interaction research from the 60s, which has not changed. These statistics, are true of human beings rather than of machines. People start to perceive that computers are not responding instantaneously at the threshold of about 100 milliseconds. And that's kind of really important because there's a certain gray area after 100 milliseconds where the user starts to lose the feeling that they're operating directly on the data, and eventually they lose their train of thought. They become unable to really follow the application at a certain point. And at the 380 millisecond point, we are well within that range. We are well on our way toward distracting the user. And we don't want to distract the user. We don't want to remind the user that they're using software. They become conscious of the fact that they're using software. And we want our applications to be transparent. We want them to be experiences, not software, right? We want them to be just simply things are happening, the users are acting, and they're getting responses. They lose, the illusion is that, this world that they've entered is not necessarily a machine anymore. That's ideal. So we can get this delay out of the way sometimes if we use the Viewport meta tag. This only happens in a couple of browsers. It would be really great if when we use the Viewport meta tag, the other browsers would do this too, because then we could be tying to mouse events or click events, and then our lives would be a lot easier. Unfortunately, this is not the case. These are the only two browsers in which the Viewport meta tag will eliminate the delay. This is your standard Viewport meta tag when you're setting up your page for mobile, so that you've grabbed control of the layout. You're no longer doing that big zoom thing, where the user zooms into the page. You can lay out a mobile page the way you want to lay it out. So this is a good thing to have. But we've really got a clear choice here. We can have a laggy interface and play it safe with click, or we can do some work and we can tie some events to touch. And I think it's a pretty clear choice. If you want to have something that's really good, you're going to want to address touch directly. So let's go over touch events. Here's where you might find touch event support. The big outliers here are Opera Mini, which obviously doesn't run JavaScript at all, and Internet Explorer. Internet Explorer has only had mouse events up until IE 9, or through IE 9, and IE 10 will introduce their new model, which is a pointer-to-pointer event. Now there are two versions of this touch event specification, and they build on each other. Version 1 is the one that we're used to, the one I described earlier. Version 2 adds some extra stuff, and I'll go over that. So here's the events. Obviously, the touch start, touch move, touch end. Touch cancel is when you get too many fingers on the screen for the device to handle, and it has to cancel the event. It's like kind of errors out, and that event is exposed so you can handle that situation gracefully. Inside the events that are passed to your event handlers, you get this event object, and that object has some properties that are very useful. It has the general properties that it inherits from its parent, which is UI event, which makes it sort of like a sister or a brother to mouse event. And but it gets these other things, these arrays of the touches, and those correspond to the fingers on the screen. So you have your touches, which is like all the touches that are going on at that moment. You have your target touches, which is just the touches that are in your actual element of your concern. And the change touches is kind of what it sounds like, just the touches that are generating new events right now. Each touch inside that array also has some properties that are extremely useful, and these are your basic coordinates. Page X and client X are essentially the same unless you've scrolled. At that point they become different. And screen X is less useful because it includes all the chrome around the screen. The target is the element that the event is firing on, and the identifier is a unique identifier in case you need to keep track. Page X is what I'm usually using almost all the time. The methods that we get our standard ones from UI event again, like things like prevent default and stop propagation. Prevent default is your friend in a big way, because if you call prevent default on the event object that comes into your event handler, you will be able to prevent the mouse events from firing. And that's very useful when you want to kind of divide your experience along, is the user using touch or is the user using mouse, and I'm going to do different things. Maybe I might tie the same event handler to mouse and tie it to touch, but inside of my touch, or at least like some kind of version of it inside of to the touch, and then I would want to derail the mouse if I know that the user has just used a touch, right? So that's kind of an important piece of logic that you can utilize. And of course, if you're creating synthetic events, you're going to want to, you have these corresponding, methods in the other events too, like init mouse event. Well, we have an init touch event here. So that's for like creating custom events. Maybe you might use it for testing or some other use. So version 2 has some new events, which are touch enter and touch leave. Those correspond very much to like mouse over and mouse leave. So, and we also get a new property, which is the related target, whatever element you are either coming from or going to. But here's where things get really cool. You get these new touch properties in V2, like the radius of the actual amount of surface you have touched. You also get the rotation angle of the oval that your finger created on the screen. So if like your finger came down like that, it would be like, that would be the angle. And then you also get force, and this is the one I'm most excited about because there's like musical applications, or who knows what you could do with force, right? There's all kinds of fun things. So just to show that briefly, just a sec here. Fire this up. This is my new Nexus. So if I hit this, I can hit this softly, and I get like a dark red here, right? And if I hit it hard,
we don't see the screen.
Oh, whoops! This didn't work over there. Hold on a second. Excuse me. Okay. So like I'm saying, if you hit it softly, you get like this nice dark red. And if I hit it hard, it brightens up. That's kind of cool. I mean, obviously this is just a demo, but I mean, hook it up to the web API, maybe it's just MIDI, you know, you got yourself some cool stuff going on. So let's move back to the prezo. Okay, so these are prefixed right now in Firefox and Chrome, so watch out for that. So now we've got the data, now we want to make some events. We want to actually make some event handlers to do some stuff. So first, before we do that, we want to set up our page properly, make sure that we're ready for touch. I talked about the viewport. That's up there again. Can everybody see that? Is that a little too small? And then if you want to lock down the scrolling entirely, maybe I can do some trickery here. Can I do this? Yeah, it's not going to let me zoom. So if you do want to get in and really lock down the screen, let's say your interface is kind of like a series of cards that you're swiping through, right? You can lock down scroll entirely by calling event prevent default on the event, on the touch move event on the window. And that will also prevent the iOS little squiggly thing that happens. You know, when you kind of move around the screen and kind of goes like that. So that can be useful. Also, setting up the page, you want to prevent some of these things that our browsers have put into the user interface that are kind of annoying, like you hold your finger on the screen a little while and you get this dialogue that pops up. If you want to prevent that from happening, there are some CSS hacks to sort of prevent that stuff. User select, that's one where you accidentally kind of are constantly selecting text. Touch callout is that dialog box that I mentioned. User drag prevents it from you can drag an image out of an element and then it snaps back again. It's super irritating. And then also when you're doing your tap highlight color on links and stuff, sometimes you don't want it to turn that color. It doesn't, maybe, you can set the color, you know, or just turn it off entirely by using these zeros. So that we're ready to start with our animations and get some hardware acceleration going on. So what's hardware acceleration? That's moving your operations over to the graphics processing unit. And what that means is you're taking the job of painting on the screen and taking it away from the CPU, which usually does it, and giving it to the GPU, which is a specialist in that task. And that's what's really cool about that is it's actually multi-core programming, which means you're kind of splitting things into threads at that point, and you're freeing up the CPU to do other stuff, other work, like calculations, figuring out how big things should be, or how fast something should respond, or what should happen next. While GPU just takes care of all that expensive painting, which is kind of difficult to do. So you're going to see much improved performance from this. There are some CSS hacks for hardware acceleration. Pretty much any transition gets hardware accelerated. And also any 3D transform. Now the difference between transition and transform, for those of you who don't know, a transition is something that you declaratively create in CSS. It's not as useful in a responsive kind of I want to drag things around context. It's more useful when you want to set something up and let it run. Right? I want to click on a button and I want to see a drawer drop down. You might use a transition for something like that. If you want to drag something around, you kind of have to be doing something every frame, right, and adjusting what's happening in the application. And for that, you want to have JavaScript interacting with 3D transforms. So if you are doing some stuff and you don't happen to be using the third dimension, you're just using some other 2D declarations, you can hack the third dimension by just saying translate 3D 000 or translate Z0, you're essentially saying, I want you to be three-dimensional, but you're not three-dimensional. So that's very useful as well. But we want to make sure that we're got it running right, because who knows, maybe the browser quirk, we never know. We've got to make sure that we've got the hardware acceleration running. So what we do is we either we get into our flags in Chrome, or we get into Safari or the iPhone simulator from the terminal. So you can launch Safari or the iPhone simulator from terminal with this code, or you can set these flags in Chrome. So let me just show you what that looks like briefly. Here's Chrome. Okay, so here I've got the flags set up, and you can see I've got these boxes around this stuff. And I'm using the touch events emulator in Chrome to get this doing, which is why I have the dev tools open to the side, because it only runs when the dev tools are open. And so you can see that with the box around it, that does mean that I have the hardware acceleration that I'm expecting to have. I also have that indicator in the corner. You see that graph up there? That's the frames per second, and that's also indicating, that only appears when you have hardware acceleration going on. So let me just, I'm also going to do this crazy thing where we start this up from the command line. Okay, here's the terminal. And let me just zoom in on that real quick. So there I'm gonna just use my arrow key and use that same command again. And I'm gonna go ahead and launch that. Okay, then that's happening in terminal. Zoom out of here. And lo and behold, on my other screen, just a second, if I can. There we go. Here's the here's the iPad simulator, and with all of its hardware acceleration extra colors activated. And so if I go to Safari at this point, and bring this up, let's start this first one first. Here's my non-accelerated example, right? I'm turning this, I don't have any colors, no hardware acceleration going on. Looks great in the simulator, it looks terrible on Android. And here, I've got a 3D transform going on, and there I've got the color, so I know that I have the hardware acceleration that I'm expecting. Okay, so let's take a look at what that looks like as well, actually on a device. Because this is where it really becomes clear. Okay, let's look at those examples again. And here's my Android, and this is like state-of-the-art Android, right? This is like the S3, Nexus thing. And this is Chrome, too. I mean, this is like the best it gets, right? So here I am, I'm doing this, and it's losing the tracking on the finger a little bit, and it kind of looks a little bit like Speed Racer, and not so great, not so smooth. The webcam here actually makes it look better than it is in real life. So, but here I've got the hardware acceleration, and it's nice and buttery, really nice. Right? And I can do that, and it spins, and it's looking pretty good. Okay? So that's pretty cool. So that's definitely something to look for and to do. Okay. So more performance things to keep in mind. Throttling your frame rate, or also getting things rolling with request animation frame. What you want to do is ideally be matching up with 60 frames a second, which is the refresh rate of the screen. And you don't want to be trying to go faster than that, ideally, or in a way that's out of sync with that at least. And you could go faster than that, but as long as you stay in sync. And the slower you get, also, you get degraded animations. So we really want to be at 60 frames a second ideally. The request animation frame will attempt to do that. It will look for the right window of time to sync up with the refresh rate and pop the animation in right at that moment. That's a good thing to do. If you want to do like the poor person's frame rate throttling, which you may have to do on browsers that don't support request animation frame, you can simply set up a stateful variable and say, like, what's the last time I did this? Like, I've got a touch move going on, right? And what's the last moment that this happened? Am I 17 milliseconds past that right now? If I am past that, I'm going to go ahead and move forward with the rest of the event handler. If I'm not past that, I'm just going to return out of the function, right? And wait for the next move, right? That's like the cheap way of doing throttling. And if you need throttling, it will actually look like your animation is slow, which is counterintuitive. You would need to kind of slow the animation down to make it look fast, right? But yeah, I had to learn that the hard way. So anyway, another thing is temporarily name your anonymous functions so they can be profiled. That's just a good debugging technique. So your event handlers, give them names, and that can help you find them in the DevTools. And also, you want to separate reading and writing to the DOM. Do all your reading at once in a big batch, right? And then when you're ready to write to the DOM, do all that all at the same time. If you do those two things in batches like that, you will get increased performance. And likewise, just write to the DOM as little as possible. I mean, just touch the DOM as little as possible, because the DOM is incredibly slow. So you want to do things like in document fragments, pop those document fragments into your application, rather than building elements one at a time in your DOM, right? You build them outside the DOM in a document fragment, get it ready, pop it in. Also, accidental browser layout reflow. That's like saying display none inside of the loop, or something like that. That would be, or checking the offset width of any element. There's these accidental things you can do that will cause the entire browser to repaint. And Paul Irish has a good list of those things on his blog, and well worth checking those out. It's a long list, and so it's good to try to become familiar with some of the things that can accidentally cause a reflow to happen. And then animated CSS shadows and gradients. These are a performance killer. So sometimes you want to maybe have a discussion with the designer, or redo the design yourself with the designer around these CSS shadows and gradients if they need to be animated, right? It's when they get into motion that they really start killing the browser. Gesture events, I just want to mention them. They are available in Mobile Safari, and they are useful for prototyping because they do make things easier, especially around rotation and scale. But they're not supported anywhere else, so they're really not worth it for production. You can do everything you can do with gesture events with the touch events. It just takes a little more math, a little more work, but then it's cross-browser compliant. But we really want gestures, right? We want to be able to do all these fancy things. We want to be able to rotate things. We want to be able to long press and scale. We want to do all that stuff. So what are we going to do about that? Also, how are we going to tell the difference between what's a drag and what's a swipe, right? I mean, if I'm moving my finger across the screen, how do you know? So it is actually kind of hard to tell. You have to set up logic to figure out from this very limited amount of data that you have in those touch objects, like the page X and the page Y and stuff. There's a very limited amount of data that you have, and so you're going to have to do some work around that. And I think that that's a good place, because there's a lot of logic and math to maintain, that's a good place for libraries. Like, find a library that does that kind of stuff. Now, this is where I talk about libraries, and also where I plug Touchy. Touchy is a library that I've written around this problem. And there are other libraries that I'm also going to talk about today. Touchy is a jQuery plugin. Hammer.js is another great library, and I'll talk about that in a second. JGestures is an interesting one because it gives you things like shapes, like shaped phone. So there's some funny ones in JGestures, and that's why I come up with it. And then there's Zepto, which is your jQuery drop-in for mobile, right? But it comes with all these nice gesture handlers as well, which is convenient, right? So that's a pretty cool one. And then there's this great GitHub site, and this is well worth bookmarking. This is like a huge list maintained by people like, folks from Google and stuff like that. Lots of people contributing to this list to maintain this list of touch libraries. So this is on GitHub, so this is a good one. I'm going to talk a little bit about Touchy and Hammer.js. Touchy is highly configurable, and it helps you manage emats. It's sponsored by my employer, Hot Studio, and on our roadmap, we have a vanilla JS version, a mouse fallback, and IE10 support coming. But where Touchy really shines is this differentiation between different types of events. And that was the problem that I was facing when I initially did the initial work on it, and then re-architected it and published it on GitHub. It's loosely based on iOS. That's sort of the gold standard I was searching for. These same names are in iOS. The only two that are in iOS that this does not, that Touchy does not do are tap and double tap. And tap will probably make its way into Touchy eventually, but double tap, I have to say, I'm kind of opposed to double tap for the same reason I mentioned earlier in the talk, and I will probably never implement that. And I would like to generally say, for the record, that I'm kind of opposed to double tap. I think it's a bad idea. It's a user interface that's based on waiting. And I don't think that means, I just don't think that's a good interface. So, event handlers in Touchy receive this phase of the event. So if you're doing a Touchy drag, you get inside the event object that comes back to you. You can start, you get in the phase property, you could say like start, or it might say move, or it might say end. And those are helpful for putting a switch in that event handler and keeping all that code together in one place and handling different things. Like you want to say on start, you want to highlight things, but on move, you're going to actually start to do stuff. So, and then touchyjs.org is the address to check it out, and there is also a Twitter account. Hammer.js is a lot like Touchy, and in many ways is better than Touchy. Now, Touchy's going to be better than Hammer.js eventually, right? The competition is good, but I have to hand it to Hammer.js. Hammer.js is pretty awesome. It's a little less flexible. And I mean, it's probably a lot less flexible actually, but where it makes up for that in that it supports like IE8 and IE10, which is amazing. It has those extra events like the dreaded double tap, and it also comes in Vanilla.js if you want it. Awesome. So definitely check out Hammer.js. I think a lot of people are kind of like getting into it. Seems to be very popular. So let's talk about pointer events with what time we have left. They've submitted a W3 proposal, and it has been accepted for the process that things have to go through at the W3C. It abstracts mouse, touch, and stylus into this unified event model, so all of those things, you can write against them in one place. Right? And you can also, what's really cool, is like say a person is using their mouse and then they touch their screen, like those two things can work together at that point. Right? They're not separate. I mean, they are separate, but they're the same. Right? So they can kind of work together. It also inherits from UI event, but it is, unlike touch, there are independent events going on. You don't get this array of touches. Everything is independent of itself. And you have to put things together yourself. Now, in IE10 for Windows 8, it's there and you can start playing with it. They have objects to help you put them together. That part of the specification that's happening in IE10 did not go to the W3C, and I don't know why, but because I feel like we need something around this to associate these events with each other when we want them to be associated. It is, however, going to be awesome for styluses, or styli. It's going to have pressure and also tilt X and tilt Y of the stylus. So you can imagine the expressiveness that's going to be possible for the stylus. Like you can like press harder and get a bigger line as you're drawing. It's going to be very artistic. So that could be great. I think it might be used in gaming consoles. I don't know this for sure. I know there's that other one, the Gamepad API in WebKit that's competing with this. But I keep thinking when I was studying the pointer event specification, I kept feeling like there's these other applications. I know there's these other applications that Microsoft is going to start springing this into. And I think maybe gaming consoles would be one, primarily because there's a bunch of buttons available on pointer events. You can have up to 5 buttons. And they're independent, so you can have 2 different people operating 2 different pointers with their 5 buttons at the same time. But we don't have gestures. And so there's some outstanding questions for the W3C specifications. How are we really going to associate these? And what happens with multi-touch and multiple people? How do we differentiate? How are we going to handle that situation? Let's talk about what's really going on in IE10. They implement some standard gestures like long press, and there's like pinch to transform and rotate and things like that. But if you want to start doing custom gestures, there's a bit of boilerplate to get that running, which is unfortunate. but it's not that bad. And it pays off for itself, because in the end, you get inertia for free. Like also that rotating thing I showed you earlier, like that, there's a bunch of code around that. All that happens like automatically behind anything, which is sweet. Unfortunately, however, though, the event data values are all matrix values, so you're going to have to get with matrix math. Yeah, so hopefully there'll be libraries for that. So yeah, but let's talk about how to get it rolling. First of all, there's some CSS, just like there was in the other browsers, to kind of like derail some standard behavior and to kind of get a hold of the environment. So we want to like touch action and user select. User select is actually in the other one too. And then here's our boilerplate. Here's our JavaScript. So we're going to create a gesture. We're going to create a gesture object. We're going to get a reference to our element, and then we're going to assign that element to the target of the gesture. Okay. At that point, we can create an event listener on our element that will, as pointer events come in, add them to the gesture. Okay, so this is like the boilerplate environment that now will trigger gesture events. Like there's no gesture events being triggered here. This is just the boilerplate to get gesture events to even happen. Okay, in a custom gesture event. So then if we move on to our event listener, we can listen at that point to gesture change, but we're going to be in matrix land at that point. So we're going to get our matrix, our old matrix. We can then transform the matrix with some methods that are available on the CSS matrix. That the values that have come in from the event, like rotation, scale, and translation, those dovetail into those methods really nicely. And then we can do our transformation and get things happening. I will show this one to you right now. So this is this laptop or this tablet, this IE 10 Windows 8 tablet was graciously loaned to me by Hot Studio. And 1 second here. Okay. Now. What are we doing? Yes. Yes, here we are. Let's see. Okay. Here's our custom gesture. So the code I just showed you is going to allow us to do this. Okay. So now I'm like taking the thing and I can transform it. I can turn it around. And this is really buttery smooth. It's really nice. And it also has this wonderful inertia effect. Right? So everything that I'm doing has inertia tied into it, like through some kind of like recursive calling of the same transformation that I had before. And I didn't have to write anything to make that happen. Pretty cool. I can stop the inertia from happening with a single line of code. Okay, there's just like a flag you set. It's like if it comes in and you're an inertia event and you're cycling through me recursively, stop. And then you stopped it. So that's pretty nice. Okay, so Pointer.js is a project by Boris of Google, and that attempts to do a polyfill to get WebKit browsers to act like IE. Is that the weirdest thing you've ever heard of? So, and he's not alone, because he was criticized because it still doesn't trigger the events on the movement, right? It's supposed to, the pointer event specification is supposed to trigger more events as you move across, and it's actually like touch events just tied back to the original element. You're not getting those extra events happening. And so this guy, Daniel Friedman, stepped in and he created Pointer Events JS, also he's at Google. And this is looking like the one, although Boris is totally brilliant and you should read his blog, because he knows way more about touch than anybody else. But this guy is writing this now, and this looks like this may be the one. If we do want to do pointer events across all browsers, this is going to give it to us. But we'll see. We'll see which happens. So now I just want to finish up with some talk about haptic feedback and what the future might look like. Haptics are really cool, and we can get them now in Firefox for Android. So if you want to start playing with them right now, it's the only browser that's actually gone through and implemented a specification around vibration API. In my experiments with it, I've realized, so there it is down there, navigator.vibrate, and then you say how many milliseconds you want the device to vibrate for. In my experiments, you just want a very tiny little vibration, right? I mean, if you start doing it for like 100 milliseconds, it's like it's a bzzz, and you don't want that. You want just like a light little feedback. Just so, like, if my finger goes over the entire button, like I've got a really small button, I still know that I touched it. I touched it, and the device told me, I heard you. And that is so nice. So we can start doing that soon, although it'll probably trickle in as the browser vendors start to implement it. I could show you that one too, but I'm not sure it's that important. So yes. So anyway, I included it here with some background styling to show you that, like, yeah, I would highlight the event, I would highlight the button or whatever it is, and then I would also do the little vibration, right? And then I would take away the highlighting on the lifting of the finger. So, so post-touch. So touch is awesome, but it is also limited in some ways by this sort of phenomenon of being pictures under glass. It's not really quite, the pictures under glass is a phrase from Brett Victor, who is another guy who's totally brilliant. And Brett Victor is talking about that as, it's not really the end-all user interface. The end-all user interface are things like hammers, right? Like that's like the ultimate. We want to be able to like feel the weight change and like feel the texture and all that stuff. And now we're going to get closer with things like feel screens. Feel screens are screens that actually emit a small haptic feedback with a small electrical charge underneath your skin, and they can create the feeling of texture. Even though it's still smooth glass, they give you a little something to help you feel like an edge of something. Right? So we're going to get a little bit closer there with feel screens. It's probably not going to get to the browsers anytime soon. What might happen in the browser soon is motion capture. And that is actually like more realistic for our near-term. Because I think it's possible that pointer events will be able to be utilized for motion capture as well. Because they are independent, and you could have potentially a lot of them going on in the browser. Say you had, enough to do every joint in your body, for example. You could get things going on in a really cool way with motion capture. And so we'll see what happens with Xbox and IE for Xbox, and how the Kinect might get utilized there. But we may see that sooner than we see field screens. So that's like some future stuff, who knows, maybe. But I think that something will happen with motion capture probably pretty soon. And as like I was saying, as I was reading through the specification and learning all about Harmony events, I just had this feeling like, I know Microsoft is all about the Kinect. I know that's what they're all about. And I have this feeling that maybe this is one way they might bring the Kinect into the browser. So, for the win, to let you go with, click is not good enough. Okay? I really feel strongly about that, and I really think that it's holding the web back. It's producing laggy interfaces, and that gives the web a bad name. So I think it's time to move on to really doing the hard work of addressing touch. Also, there's all kinds of great stuff available for you in hardware accelerated CSS. Explore IE10, it's very cool, kind of, in some ways. The pointer events are really cool, so check those out. And I just want to say thank you for being awesome. You're web developers, so therefore you are awesome. Okay. I would take questions on the Twitter feed, but also if anybody wants to ask a real question out loud, that's cool too. Yes?
they comment on the GPU acceleration and also the library support if you use PhoneGap.
Hardware acceleration in PhoneGap. The JavaScript engine is not as fast, but the what's called composited acceleration is still available in the web. So it can still work. The speed at which the JavaScript works is not as fast in PhoneGap. So it uses the same exact engine. Is that right? Did I have that right? And but the hardware acceleration will be there. Oh yeah, I'm sorry, the last screen. Sorry, there's the PDF. There's going to be an accompanying blog post on our new blog at Hop Studio, which is called Hot Labs. And yeah, so there's some resources. So there will be an accompanying blog post, like literally within 24 hours. And also the PDF is already up right now. Anyway, I'm sorry, another real question. Yeah. Oh my goodness, don't scroll. Don't take control of scroll. Taking control of scroll is the worst design decision you can make in an application. Use native scrolling. Facebook, you remember Zuckerberg's comments about HTML5? This was because of scrolling. I mean, well, it wasn't entirely because of scrolling, but it was a lot because of scrolling. Because they scrolled, doing custom scrolling, first of all, never maps to native accurately. And secondly, it consumes massive amounts of memory that you want to have available for other things. You have the native scrolling in place. I would say that we need to design appropriately for the web platform. And taking control of scrolling in that way, unless you are going to do things like I was saying, like swiping through cards, something like that, that's fine. But like trying to get like say vertical scroll and horizontal scroll in like a swipey way at the same time, you're trying to take a native metaphor and put it on the web platform at that point. And I think that is a big mistake. So I would always bet against taking control of scrolling. You build vertical interfaces is one way to do it, or you derail scrolling entirely, and you're doing CSS hardware-accelerated animations to simply move things around in a single plane. But you're not like presenting a scroll bar or expecting like that sort of that same sort of experience that you would get out of native scrolling. See what I'm saying? Well, let's say I had a very simple horizontal scroll, right? I just have these pictures, and I wanted to move through them quickly. That would be fine, right? Because I would actually have no scrolling going on, and I would just be having this one big element, maybe, or maybe a set of elements that's like shifting here and there, right? Going back and forth. That's not quite the same as like, whatever content comes in, I'm just going to be able to like, or I'm going to have a div within a div, and that sub-div is going to scroll, and I'm going to put a custom scroll bar on it, and all that stuff. And then on top of that, then I'm going to also swipe to the side, and I'm going to have a whole new page. That's where we're probably going to think. I mean, if people can do it, great. But I mean, I think those are big challenges.
What's your thought on like third-party hardware like Leap Motion interaction with?
Oh, the Leap. I'm totally stoked with the Leap. I mean, it sounds really cool. I mean, I don't think that motion capture is ever going to replace touch, and I should say that because you're still back in that avatar, right? Where I'm doing something here, and I'm seeing it reflected here, and the human being actually wants to really just actually touch it. But it's still cool, and I'm really excited to see it happen. We'll see if we can get it in the browsers or not, or if it's only native for a long time. Yeah?
If you're doing animations, should you always opt for 3D animation, or is there a time where 2D animations would be faster?
I would say that you'll have to play that by ear a little bit. There are times when 3D animations can run into flicker And there are some CSS declarations to prevent that. And I'm sorry to present that today, and I can't, rattle them off. But there are some, it's like the backface. Yeah, can somebody rattle it off? The backface thing? I can't remember what it is. It's like whether or not the backface is visible of the object. And if you say it's not visible, then you will prevent that flicker from happening. So sometimes 2D transforms can run into problems, but most of the time they're great.
From the question that I wanted to ask before, you wouldn't suggest never to customize events, such as scrolling and so on?
I don't know if I would never do anything that was supposed to be native, but I would be wary of that. I mean, I think that one of the things that I think that we should be doing in design for the web is saying we're not native. This is a whole new, this is its own paradigm, that is the web paradigm, right? And not this proprietary platform. And I think that, I would be reticent to bring in the wheel for just to try to match it. Yeah, go back.
Could you verify if that link is working? I can't seem to get it working. Your presentation, the PDF
working.
file. Yeah, working.
Capital letters?
Okay. Yeah, I tried that. Maybe it's just the Wi-Fi.
Yeah, I pulled it up earlier, so I think it is there.
Okay. Thank you.
Hey, thanks a lot, everybody.